Oops, my phone died, sorry. So the negative root of 9 is negative 3. The negative root of 4 is negative 2. So which one of these, negative 9 or negative 4, is this closer to? It's closer to negative 2. So this would be the negative square root of 5. Okay, we're not using calculators, but if I did, it's 2.236, but it's negative. So negative 2.236. Okay, so that comes here. And then I have the square root of 13. So I know that the square root of 9 is 3. And I know that the square root of 16 is 4. So is the square root of 13 closer to 16 or 9? What's closer to 16? So that's where this goes. So now it's really important when I write them in order, okay, that I put them in their original format. So I have negative 2.5, then I have the negative square root of 5, then I have 4/3, then I have the square root of 9, and then I have the square root of 13. Okay, so why don't you try this last one down here, and then we'll see how we'll see what you get. Okay, so I am not going to use a number line this time. I'm just going to look at my numbers. I know that this is negative 4.5, right? I know that. I know that this is closest to, if I'm going to approximate this, it's closer to negative 4 than negative 5 because it would be in between the square root of 16 and the square root of 25, and it would be closer to the square root of 16. So as far as my negatives go, these are the only ones I'm dealing with. And I know that negative 9 over 2 is less than the negative root of 20 because this is negative 4.5 and this is closer to negative 4. Okay, so now I have my positives. So there's 0. Thank goodness, that one's easy. I know where it goes. Okay, so now I have the square root of 7. Okay, I obviously know 4.1 comes before 5.2, but I need to figure out where this one goes. Okay, so the square root of 7, I know the square root of 4 is 2. I know the square root of 9 is 3. And the square root of 7 would come in between the square root of 4 and the square root of 9. So this, that's telling me, is going to be somewhere in between 2 and 3. So like, just make it up, 2.4, whatever it is. Okay, but that is less than 4.1, so this comes next. And then 4.1. And then 5.2. Okay, if you prefer to use a number line, then by all means use a number line, but you definitely don't have to. Okay, and then the last thing that we're going to talk about, or I guess not last, there's one more thing. Okay, let's look at this table that we have up here, okay, for classifying numbers. So the square root of 24, okay, is that a real number? And you're like, well, that's irrational, right? Because I don't know the square root of 24. If I type that in, it's never going to end and it's never going to repeat. So I'm looking at my little chart over here. So if it's irrational, is it rational, integer, or whole? No, it's not rational, it's irrational. Therefore, it's not an integer or a whole. Is it a real number? Yes, because all of these are real numbers. Okay, the square root of 100, is it real? Yes. Is it rational? 100%. I know the square root of 100 is 10. It is a rational number. Therefore, it is not irrational. Is it an integer? Yeah, it's 10, right? 10 is an integer. Is it a whole number? It is, because it is a counting number. Okay, and then I have the negative root of 81. So that's negative 9. Is that real? Yes. Is that rational? Yes. Is it irrational? Nope. Is it an integer? Yes. Is it a whole number? No, because it's negative, right? Whole numbers are your positive counting numbers. Okay, now we're going to get into conditional statements. Okay, these are if-then. It says rewrite the conditional statement in if-then form. Then tell whether it's true or false. If it's false, we're going to give what's called a counter example. Okay, that's pretty much an example that's just proving that it's false. Okay, so what we're given here is no fractions are irrational numbers. Okay, so to write it in if-then, we're going to say if a number is a fraction, then it is not an irrational number. Okay, so I took my statement that no fractions are irrational numbers, and I turned it into if-then. So if it's a fraction, then it is not irrational because it says no fractions. Okay, so is that true or false? If a number is a fraction, then it is not irrational. That's true, right? If it's a fraction, then it's automatically rational. We are writing it as a ratio, right? The definition of irrational is that you can't write it as a fraction. So if we are writing it as a fraction, then automatically it is rational. Okay, so look at the next one. So let's read it. It says all real numbers are rational numbers. Okay, so how could we write that as if-then? If it's this, then it's this. Okay, so it would be if a number is real, then it is rational. Okay, if a number is real, then it is rational. True or false? Feel free to look back on your last page. If it's real, then it's rational. That is false. Okay, and our counter example would be something like the square root of 20 is real. That's a real number, but irrational. Okay, and look at this last one. All repeating decimals are irrational numbers. Okay, so if it is repeating, then it is irrational, right? The statement is saying if a decimal is repeating, then it is irrational. Is that true or false? That is false. Okay, and my counterexample is just something like a third, right? Because that's repeating, but that's a rational number. I just wrote that as a ratio.